Okay, finding the sum of an infinite geometric sequence. Um, there is a formula for the sum of an infinite geometric sequence, and again, I will give you the formulas. The formula is your sum of the infinite geometric series is your first term over 1 minus the ratio. It is the nicest of the formulas. Um, so all we have to do is identify the first term and the ratio, and I'm telling you it's an infinite geometric series, so there's no guesswork here. You don't have to see if it's geometric or whatever. The only thing you have to remember is that you can only do this if your ratio is between -1 and 1. Um, the Math League of America probably would say if the absolute value of the ratio is less than 1, which is the same thing. So remember that this only works if your ratio is between -1 and 1. So let's see, I can already tell my first term is 1, but I need to find the ratio. So my ratio is going to be my second term divided by my first term. 1/2 divided by 1 is 1/2. And just to make doubly sure that I did the ratio correctly, I'll find the ratio for the next two also, from 1/2 to 1/4. That'll be 1/4 divided by 1/2, which is the same thing as 1/4 times, 1/4 times the reciprocal of that one. So times 2 over 1, which is 2 over 4, which is 1/2. So I know that my ratio is 1/2. And the only other thing I need for my formula is the first term. My first term is 1, and so we'll take that, and the sum is going to be my first term, 1 over 1 minus the ratio, and then we'll clean that up. 1 minus 1/2 is 1/2. 1 divided by 1/2 is the same thing as 1 times, you flip and multiply, 2 over 1. And 1 times 2 is 2. So there is your sum for this one. Find the ratio, first term, plug it into the formula. Just make sure your ratio is less than 1, which 1/2 is, or between -1 and 1. All right, let's see. Again, sum of an infinite geometric sequence. I need to find the ratio. So if I found the ratio between, say, these two, my ratio is, that's -4 over 6, which is -2/3. And just to be doubly sure that I did that right, I'm going to find the ratio between these two terms as well. That'll be -16 over 9 times 8/3, which you would flip and multiply, so -16 over 9 times 3 over 8. Let's see, I can cancel that. 3 goes into 9 3 times. 8 goes into -16 -2 times. And everything canceled except the -2 and the 3. That's the same ratio I got up there. So I know my ratio is -2/3. And the only other thing I need for my formula is my first term, which is 6, because I do know that the sum is my first term over 1 minus the ratio. So I'll take those, and my sum ends up being 6 over 1 minus my ratio, which is -2/3. And then we'll clean that up. That's 6 over 1 minus -2/3. We'd get a common denominator, which would be 3. So 1 is 3 over 3 plus 2 over 3, which is 5 over 3. Flip and multiply. That's 6 divided by that fraction. So we would multiply by the reciprocal of that fraction. And 6 times 3 over 5. 6 times 3 is 18. And the 6 is over a 1. Remember, when you multiply fractions, you just multiply straight across. And 1 times 5 is 5. So there is your sum of that infinite geometric sequence, or series. And remember that it works when the ratio is between -1 and 1, and -2/3 is between -1 and 1. This one, same type problem, except here I've given it to you in sigma notation, which means you have to do a little bit of work. Now, one of the things hopefully you remember is that a geometric sequence is always in the form your first term times, or I would say a term times, -3/4 to the n minus 1 power. Not -3/4 times the ratio to the n minus 1 power. And the thing about that is the number that's being raised to the n power is always going to be your ratio. So I can look at this and just know from the general structure of it that my ratio is going to be -3/4. Now, if you forget that, you could always just write out the first two terms and find the ratio algebraically. If I plug in 1 for k, that'll be 3 times negative 3 fourths to the 1 minus 1, which is 3 times negative 3 fourths to the 0 is 1, and 3 times 1 is 3. My next term would be 3 times negative 3 fourths to the 2 minus 1, because I'm plugging in 2 for k now. I started at 1, plug in 2. That would be 3 times negative 3 fourths. The 3 is over a 1, so we would multiply straight across. 3 times negative 3 is negative 9. 1 times 4 is 4. And if you found the ratio between the first and second terms, your ratio is you divide the second term by the first. Negative 9 over 4 divided by 3. You would flip and multiply, so negative 9 over 4 times 1 over 3. And then you could cancel 3 goes into 9 3 times, except that's negative 3 times 1 over 4 times, and that would be a 1 because it canceled, which is 4. And you do get a ratio of negative 3 fourths. So there's my ratio. The first term, and the safest way to get the first term is to actually plug in the very first value of k. And when I plugged in 1, I did get 3 for the first term. And then I would use that, and the sum is going to be the first term over 1 minus the ratio of negative 3 fourths. Let's see, I would get a common denominator on bottom. So 1 is 4 over 4 minus a negative would be plus 3 fourths. So I have 3 divided by 4 plus 3 is 7. The denominator doesn't change. We will flip and multiply that denominator. 3 times 4 over 7. 3 times 4 is 12. The 3 is over 1. 1 times 7 is 7. And there is your sum. And so there is the sum of an infinite geometric series. And yep, that was it.